Hi, all. Good evening, everyone. In today's session, we are going to discuss about threads and concurrency, the multi-threading concept. So, as we discussed in a previous session, if you want to create our customized exception, then we could create a customized exception by extending the exception class or runtime exception. Similarly, if you want to implement thread concept, if you want to implement multi-threading, then our class has to extend the thread. It means our class has to inherit by thread class. So now I have created one class, that is my first thread. This is a normal class which is defined by user. So this is a normal class. If I want to make this class as thread, if this class has to get the behavior of thread, so I will let you know what is a thread and what is multi-threading. Multi-threading is nothing but, now we are writing the program, as well as the other side we can download some movie and we can hear the music. So here we are doing multiple tasks. It's not one task. Simultaneously we are doing multiple tasks. Writing the program, and we are downloading the movie, and we are hearing the music. So these three tasks are happening concurrently. So this is a multitasking. That was a multi-threading. So multi-threading is a concept that multiple threads execute simultaneously. Then what's a thread? What's a thread? A thread is a separate independent part of the same program is called thread. A separate independent part of the same program is called thread. So how can implement a thread? We can implement a thread by if we want to implement a thread concept, then our class, the user defined class, must get inherited by thread class. There is a class, that is a thread, provided by Java vendor. So if I want to make my first thread class as a thread, then I must inherit this class by thread class. So the inheritance is possible by using keyword, that is extends keyword. So my thread extends thread. Now all the behavior of this thread get inherited to my first thread class. Now my first thread class also behaves as thread class. Now there are some rules to implement a thread. Those are, it has to follow the thread life cycle. It has to follow a thread life cycle. If it did not follow the thread life cycle, then it will not, it's not possible to implement a multi-threading. So it must follow thread life cycle. So once we complete one program, then I will let you know what's the thread life cycle. So for thread implementation, the thread is a class provided by Java vendor. This thread class have a method that is start method, and run method. Start method and run method. So previously, as we discussed, a thread is a separate independent part of the same program. So now I require two independent parts in the same program. That is, one part I am giving by using run method. So this run method is already available in thread class. Now if I want to implement this thread life cycle, then I must override the run method. So let us see how we need. Run is a method. It is already available in thread class. So this method run is a method. This is already available in thread class. So now I want to print something for 10 times. So that is, if I want to print something 10 times, then how can I print? I need a loop, that is a for loop. So I plus plus is nothing but every time it will increment by 1. So initially the I value will be 0. Initially, if the I value is 0, the next time when I plus plus, then I value will be 1. So it is a child thread. Now I'm going to create one more part of the program, one more thread, that is main thread. So main thread, the same, I want to print 10 times the main thread also, but this is not child thread, it is main thread. Okay. So one thing is, if you want to implement a thread lifecycle, then we must override the run method. This is the mandatory method. This is mandatory method. So now I have two parts of the program. Two parts. This is one part. This is a one part, that is main child thread. This is another part. It is a main thread. So now how many threads are here? Here there are two threads. This is one thread and this is one thread. It is the child thread and it is main thread. So what is a thread? So this entire is one program. This entire is one program, one class. So what's a thread? A thread is a separate independent part of the same program is called thread. So this is separate independent part of the same program. This is one separate independent part of the same program. Now, if I want to call any thread, then suppose if I want to call this run method, how can I call this run method? First, I must create an object for this class. So I'm going to create an object for this class. My first thread, mft equals new my first thread. This is the way of creating an object. So whenever I created this object, then immediately the thread will create. The thread will create. it will be a new or born state. The status of this thread now is new or born state. Now, if I want to call this method, how can we call? The general way of calling this method is mft dot run. This is the general way of calling this run method. But here in thread, when you are implementing the thread, this is not a way of calling the run method. This is the general normal way. But if you want to implement a thread, there is a thread life cycle. We have to follow the thread life cycle. In thread life cycle, if you want to call this run method, the run method has to call by start method of thread class. This thread class will have another method. So run is the one method, and the thread class will have another method, that is start method. Then start method will call this run method. So here I need to call the start method. The start method. This is a thread class method. Now this start method will call the run method. Then the thread life cycle will execute. Okay. Now see here. If I run this program, how it will be the execution? So generally the program execution in Java, the program execution will start from main method. So the cursor will come here, and then it's created an object for the first thread, my first thread, and then we are calling the my start method. So when you call the start method, thread class start method will call the thread class run method. So here there is a run method, then it will call the run method, and initially it will be a 0, and for loop initially I value is 0. Then it will check I less than or equal to 0. Now what is the I value? 0. 0 less than or equal to 10. Yes, it's a true. Then it will execute. Child thread will print, and then again it will go to the loop. In loop I plus plus is 0 plus 1. Every time it will increment by 1. I value is 0. I plus plus 0 plus 1. So the I value will be 1 now. Now 1 less than or equal to 10. Yes, it's a true. So now again it will print the child thread. So likewise it will print the child thread for 10 times. And then it will come here, and then here also we are printing the same main thread for 10 times. So you can expect the output. What will be the output? So child thread will execute for 10 times, and then main thread will execute the 10 times. But in multi-threading, so multiple threads execute concurrently. Simultaneously it will execute both threads. So this is a one thread, it will execute, then simultaneously this thread also will execute. Both threads will execute concurrently, so that we cannot expect the exact output, because both are executing concurrently. So we cannot expect the exact output, which thread will execute first and which thread will execute next. So that in threads we cannot expect the exact output. So now let us see what will be the output for this program. Let's do the right click, run as Java application. Yeah, see here. So main thread has executed for 10 times, and then child thread has executed for 10 times. So generally, which thread has to execute first? Main thread has, child thread has to execute first, and then main thread. But here we cannot expect the exact output, which thread will execute first and which thread will execute next, because both threads execute simultaneously, as well as each and every execution, the output will be different. Now the output is first main thread has executed 10 times and then child thread has executed 10 times. Now the next time again I am again I am running here. So the next time output may be differ. Now main thread has executed 10 times, child thread has executed 10 times. Main thread and child thread. Now see, main thread, main thread, main thread. So main thread has executed for 5 times and then child thread has executed for 10 times. Again main thread has executed for another 5 times. So we cannot expect the exact output of program in threads because both threads concurrently execute. So first main thread has executed for 5 times, then immediately the child thread has taken the chance to execute, then the child thread has executed for 10 times, then again main thread has executed another 10 times. So this execution will depend on thread scheduler. This execution will depend on thread scheduler. The thread scheduler will give the instructions to each thread. So you execute this and then you execute it. So based on the thread scheduler instructions, these threads will get executed. Now when I run the same program again, the output will be differ. Now see, again main thread has executed and then child thread. Now see, child thread has executed for 10 times and then main thread has executed. So we cannot expect the exact output in threads. So now I will show you the thread life cycle, how it will be the thread life cycle. So when you create an object, my first thread, MFT equal to new my first thread, then immediately the thread will be in new or born state. In this state, this is the new or born state. And then when you call start method, thread dot start method, then immediately it will be in ready or runnable state. When you call start method, then the thread will be ready or runnable state. Now it is ready to execute it. Now the thread scheduler will take the chance. So the thread scheduler allocates which thread has to execute first. The thread scheduler will allocate which thread has to execute first. Then based on the thread scheduler allocation, then the execution will start and then the run method and this thread, both threads will execute concurrently. Both threads will execute it. Run method as well as this method, because the start method will call the run method. Then both threads concurrently will execute. So we cannot expect the exact output. Both are trying to execute. So the thread scheduler instructs to execute the child thread first and then main thread next. Child thread first and then main thread. Sometimes the thread scheduler will give the chance to main thread. So here it has to execute 10 times, but it will give the thread scheduler instruct to this main thread, you execute for 4 times and then give the chance to child thread. Then the child thread will execute. So it's depend on instructions of this thread scheduler, and then it will be in running. So in the running, once it is in running state, then the run method will execute. Once the run method is executed, this run method is executed, then the thread will be in dead state. First will be, whenever we create an object, it will be a new or born state, and then when you call start method, it will be in ready or runnable state, and then The thread scheduler will allocate which thread has to execute first and which thread has to execute next. And then the run method will execute. Once the run method is executed, the thread will be in dead state. So this is the thread life cycle. Every thread has to follow this life cycle. So what's the way how we can implement a thread? If we have to implement a thread, then our class must inherit by the thread class. Must inherit by the thread class. Then our class must override the thread class run method. The thread class run method, then only it's possible to implement a thread. Otherwise we cannot. Then run method has to override. Then whatever the code we want to execute, whatever the code we want to write, that code we will write inside the run method. And then we have to create an object for this class, and then we should not call the run method directly. The run method has to call by, this run method has to call by start method of a thread class, so that when we create an thread class object, then this thread class will have a method that is the start method. Then when you call the start method, the start method will call the run method, so that the thread life cycle will fulfill. Once the thread life cycle is fulfilled, then only we have successfully implemented the thread. So this is the way of implementing a thread. So our class must inherit by the thread class, and then we have to override the run method, and this run method has to call by the start method. In case if you call, so somebody may have doubt. In case if I call instead of start method, if I call run method, then what happen? Yes, if I call run method, yes, this method will execute, but the thread will not implemented. The thread will not implement because we are not following the life cycle. If you follow the life cycle, then only the thread scheduler will allocate which thread has to execute, which thread has to. So we are not following the thread life cycle. There is no start method at all. Just the thread will be in the new or born state. It never be in the ready or runnable state. If our thread has to be in ready or runnable state, then what we have to do? We must call the start method. If you do not call the start method, then we always be in the new or born state. Yes, thread has created, it will be in the new or born state, but it never be in the ready or runnable state. If it has to be in ready and runnable state, we must call the start method. So now we can expect the exact output. Now what will be the output? The child thread will execute first. The child thread will execute first and main thread will execute next. So if you execute any number of times, the same output we can get it. Child thread will execute first and then main thread will execute it first. We can expect the output because here we are not any number of times you execute it, same output you will get it, because we are not implementing a thread here. So it will be always child thread and then main thread. We can expect the exact output. Because here we have not implemented a thread. We are not following the thread life cycle. So we must call the start method. Then the start method will call the run method. Then we are successfully following the thread life cycle. This is the way of implementing a thread. So the thread, we can implement a thread in two ways. One is by extending a thread class, Other way is by implementing runnable interface. The other way is by implementing runnable interface. One way is by extending thread class, other way is by implementing runnable interface. So two ways. So the second way is This is the second way. So my second thread implements runnable interface. Runnable is the interface. It is not a class. It is interface. So that it is implementing. As we already discussed previously, a class will extend a class, but a class implements a runnable interface. Even I explained it you previously why we'll use this extends keyword, why we'll use this implements keyword. Since it is a interface, runnable is a interface, so my second thread implements a runnable interface. Then the same way, the runnable interface will have an abstract method, that is run method. This run method is available in runnable interface. Runnable interface will have only one method, that is run method. That is run method. So we need to override the run method. So we have provided implementation for run method, and then if you want to follow thread lifecycle, then this run method has to call by start method, but the start method is not available in runnable interface. The start method is not available in runnable interface. Where is the start method? The start method is available in thread class, not in runnable interface. But the thread class implements the runnable interface internally. Internally, the thread class implements the runnable interface. It meaning that whatever the methods are available in runnable interface also available in thread class. So then the thread class can give the object for the runnable interface. So then what I do here is, first I will create an object for my second thread. My second thread, mst equal to new my second thread. Now I need a start method to call this run method. So I don't have a start method in runnable interface. So even not in my second thread. So what I have to do? I have a thread class have a start method, so that I have created an object for thread class, thread t equal new thread, and then I passed this object as thread parameter, for a thread as a parameter. Now this thread has a object of this class as well as start method. So now t dot start, then this thread class start method will call this run method. This thread class start method will call this run method. So now as per our thread lifecycle, yes, we have overridden this run method, and then when you create an object, it will be in ready or runnable state, and then we are calling the start method, thread class start method. This thread class start method will call the run method, so it will be in the ready state. Once we call the run method, then it will be in the dead state. So thread lifecycle has fulfilled. Thread lifecycle has fulfilled. So what will be the thread lifecycle? New and born state, and then start method. Here we are calling the start method. When you call the start method, it will be in ready or runnable state, and then the thread scheduler will allocate which thread has to execute it first, whether the child thread or main thread, which thread has to execute first, it will decide. Once it decides, then the run method will execute. Once the run method is executed, and then it will be in the dead state. It will be in the dead state. It means that the execution has completed and thread has dead. So we can implement a thread in two ways. We can implement multi-threading or concurrency in two ways. One is by extending the thread class. Other way is by implementing the runnable interface. The two ways. Then the question is, which is the best way? By extending a thread class or by implementing runnable interface? Which is the best way? We have two options. Then which option will go? Which is the best option? The best option is implementing runnable interface. Implementing a runnable interface is a best option, the best choice, because the reason is, now here I am implementing by extending a thread class. Now what happens? Whatever thread has a behavior, all the thread behavior will get inherited to the my first thread. My first thread. Now what I am trying to do, I want to give some other extra behavior for this my first thread. So the extra behavior is nothing but I want to extend one more class. I want to extend one more class, that is uh, just assume array list. Array list. Now immediately it will throw in a compile time error, syntax error and token. Delete this token, because a class can extend only one class. A class can extend only one class. It cannot extend more than one class. It cannot extend more than one class. A class can extend only one class. So I cannot give the array list behavior to the my first thread class. I can give only one behavior, that is either thread behavior or array list behavior. Either one behavior I can give it, but I cannot give both behaviors. So if I remove this, then it's okay. So I can give array list behavior. Now, if I want to give thread behavior also, now immediately it will throw a compile time error, syntax error and token, delete this token. It means that a class, this is a class. My first thread is a class, and thread is also a class, and array list is also a class. A class can extend only one class. It cannot extend more than one class. So, in case if my class required other behavior, the other class behavior, then there is no chance I cannot get it other class behavior. I can get only thread class behavior. I cannot get it other class behavior. So that here there is a problem, that is, if I implement by thread, I can get only thread class behavior. In case if my class required other behavior, I cannot get it. But whereas by implementing runnable interface, so here I have a thread behavior, already I have a thread behavior, and then here and extends. If you see here, now my second thread extends array list. Now the array list behavior get inherited to the my second thread and implements runnable interface. Implements runnable interface. And then the runnable interface, what this runnable interface? Runnable interface will give the thread behavior. Now my second thread has two behaviors. One is thread behavior as well as array list behavior. Thread behavior as well as array list behavior. So I can give some additional behavior to my class using by if you implement the thread using runnable interface. If I implement a thread using runnable interface, I can give some extra behavior. If my class requires some extra behavior, yes, I can provide, but that is not possible by implementing through thread, by extending thread class. If you extend the thread class, that is not possible. But if you implement by runnable interface, if my class requires some other behavior, some extra behavior, that I can provide using this extend schema. So this is the advantage of implementing a thread by runnable interface. Okay, I hope you understand. This is the interview question. What's the best way of implementing a thread, by extending the run class or by implementing the runnable interface? So obviously it will be by implementing the runnable interface. This is the cause why it is the best. This is reason it is best. Okay, and then every thread will have a priority. Every thread will have a priority. So now we have two threads. One is child thread and then main thread. We have two threads. Each thread will have a priority. The priority is every thread by default will have a priority 5. The priority range is 1 to 10. The priority range is 1 to 10. So 1 is the minimum priority, 10 is the maximum priority. The default priority, in case if you do not set any priority, the default priority of thread is